So in today's class, we will be doing pointwise mutual information, and we will be seeing with the help of examples how do we calculate the pointwise mutual information and how do we generate the pointwise mutual information matrix for a given corpus. So in the previous class we studied what are word vectors and how these word vectors are generated, and what are the advantages that we have with word vectors as compared to document vectors. So we define word vectors as word vectors or embeddings as vector of context values. And this vector can be easily represented in space. So this is a multi-dimensional space, and we can represent a vector of word. So like this, these are the different words. So different words in space which are similar, they have nearby positions with each other, something like this. So this is like not, this is a not vector, this is the good vector, not good or very good, very vector and good vector. So these are very close to each other, and in general in the corpus also we see that these two words occur very close to each other. So a word is defined, a word is defined by its surrounding words. Right? So in order to generate these vectors, we are required to calculate a co-occurrence matrix. Co-occurrence matrix is a matrix in which each value, suppose it is Fij, represents the number of times word Wi is in context of Cj. Right? So a matrix in which each value Fij represents the number of times word Wi appears in the context of a word Cj. So we can see the word context matrix like this. So for a given corpus, we have we can identify what is the vocabulary of that corpus, and each word in the vocabulary may be represented as words, target words, and context. Right. So this co-occurrence matrix has target words, so this is WI. Target words are those words that are in focus, and then we have context words in columns. So context words may be simply called as context. So these target words are also simply called as words, and context words are simply called as context, so that there is no confusion by the term word. And this is represented with CI, and each of these is represented as Fij, that is a frequency with which Wi appears along with the word Cj. Right. So these Wi's and Ci's are actually same. So for a given corpus, this is a corpus. Okay, so in this corpus, suppose we have some words like data, then we have some words information, then computer, database, something like this. So we have these words appearing at many places in the corpus. So this is data, again somewhere information. So what we do is that we define a window for context, right? So we define a window of context words. So each of these context may be based on some window size. So each context word is based on some window size, right? So suppose we have an example sentence as data is stored in memory of a computer system, right? So in this we see that all after removing stop words and cleaning and all, we are left out with the words data and stored and then memory and then computer. Data stored, memory, computer system. So these are the words that are, after cleaning the corpus, we achieve these words. And suppose I say that this memory is the target word, right? So I say that this memory is the target word. So in respect of memory, we may have, with window size plus minus 2, we have these context words. These are context words. Right? So wherever memory is present inside the corpus, the left two words and the right two words with the window size plus minus 2 will be treated as the context words. So if I take this here, all these words, data, store, and memory, let me write it in red. So this is data stored, memory, computer system. So these same words are also treated as context. Data stored, write it in green, data stored, memory, computer system. Right? So this is one case in which this kind of sentence is appearing in the corpus. In some other place, memory may also be appearing in the corpus at some other place. So there may be some other words in place of these. So now this data, when treated as target words, is appearing with data. So data kind of word is not coming anywhere, does not come anywhere in the corpus. So this will be treated as 0. Not taking this memory as the context word, sorry, the memory as target word. So memory is the target word and data stored computer system are the context words, right? So making an assumption that this is the, memory is appearing only once in this corpus, just making an assumption, if the memory word is appearing only once in the corpus, so no other words will be context if memory appears only once. So this memory is the context of data. Sorry, data is the context of word memory. So this is the memory is the target word, data is the context, it appears only once here, right? Now stored is again the context of memory and it appears once here. Similarly, computer appears once here and system appears once here, right? So this I am doing with window size co-occurrence matrix. This is co-occurrence matrix with window size plus minus 2. Now if I would have taken the window size plus minus 1, then in that case this data would not have been the context and this system would not have been the context, right? But I'm taking the context size as plus minus 2. Now let's make another assumption. Let's have another sentence that memory appears suppose somewhere other in, so memory data is computer stores data in memory, right? So when I am removing this stop word, so in will be removed, we will left out with computer stores Stores and stored will be again converted into same by lemmatization. Computer stores data memory. So we are left out with 4 words. So our target word is currently memory. So this is the target word, marking in red, and there is no word after memory, so the right side context is null. There is only a left side context, right? So now making an assumption that memory is having 2 occurrences, the memory word appears 2 times in this corpus, so I will be taking up both the instances of this memory while generating this co-occurrence matrix. So now what will be the values of this co-occurrence matrix? I will go to the word target word memory and see whether it is in context of data how many times. So in context of data with sentence 1 and sentence 2, it is now 2 times, right? With stored again it is 2 times, right? And with computer we see that the computer goes outside the window. So this is actually, this is outside the window of plus minus 2. So does not considered as context. So not considered as context. So in this case this computer remains 1 and system is not there, so it remains 1, right? So in this way we populate this co-occurrence matrix with window size plus minus 2, right? Now let's see with other words. Now data with data is 0, data as the target word, right? So data as the target word, so data is appearing with stored memory and stored memory. So stored memory is 2 here, this is also 2 here, right? Data is also appearing in context with computer. So computer is the context of data, computer is not the context of data in sentence 1, but it is in context 2, so there will be only 1. And data is again the context is system is not the context as well as in, so this is 0 now, right? Now again let's see about stored. So stored is having, so this is the context and this is the context and this is the context here and this is the context computer. So stored is in context with data, yes, at 2 places. So this is 2 here. Stored with stored is 0, and stored with memory is 1 context is here and 1 context is here, it is 2. And stored with computer is, yes, it is context, and yes, it is yes, it is context. So stored with system is not a context, stored with system is not a context, it is 0 here. Similarly we can see computer as a context. So in this way we can do for all these words that are present in the corpus by defining some kind of some window size, right? And we can populate this co-occurrence matrix of size modulus of V, that is the vocabulary size, right? So in this way we can generate the co-occurrence matrix. Now these raw counts or frequencies of words in respect of their context is not that much helpful and not that much efficient, so we go for some other probabilistic methods, and one of the probabilistic methods is pointwise mutual information. So now before going to pointwise mutual information, we may directly use the joint probabilities, right? So joint probabilities are P of x comma y. So what is the probability of a word occurring with another word, right? So joint probability of P of a comma b can be calculated with the help of these counts. But instead of using the joint probability, again it is found that pointwise mutual information is somewhat more powerful than these raw counts. Okay, so let's see what is pointwise mutual information. So pointwise mutual information is the measure of two events x and y occurring together as compared when they are occurring independently. This is occur together. So the PMI, pointwise mutual information, P of xy is P of x comma y, that is the joint probability, divided by the P of independent probabilities of x and y. So what does it mean? This P of xy actually means that this is the joint probability. So this is the joint probability, and these are the independent probabilities of x and y. Independent probabilities of x and y. So the joint probability means that the probability of P of x and y occurring together and P of x dot P of y means that P of x dot P of y means that x and y are independent events. That means the occurrence of x does not affect the occurrence of y. So if we treat that P of x and P of y are independent events, then we know that the probability can be calculated as P of x dot P of y. The probability of them occurring together can be calculated as P of x dot P of y, but treating them as independent events, that P of x does not affect y, but P of x comma y means that x and y are occurring together. Like, very good, if very is appearing, then there are very high chances that good may also appear. So that kind of probability is the joint probability. That means one word is affecting another word. Okay, so pointwise mutual information in respect of a given word W and a context C may also be defined in a similar way, that is log 2 P of W comma C divided by P of W dot P of WC. But it is often seen that the negative values of PMI, the negative values of PMI are not that much good. So we may generally use the positive pointwise mutual information. So positive pointwise mutual information means that we will be only considering those PMI values that are positive, right? So in this way we can calculate PMI values with the help of the frequency or the co-occurrence matrix that we generated earlier. So the PPMI Ij is actually the positive mutual information of Pij divided by Pi star P star j comma 0. So what is Pij, Pi star and P star j? So Pij is actually the probability no, Pij is the term in which we have the frequency of the word and the context divided by the frequency of the word alone multiplied by the frequency of the context alone, right? And Pi star is the frequency of the given word divided by the frequency of the word multiplied by the frequency of the context, and P star j is the frequency of the context divided by frequency of word multiplied by frequency of context. So let's see with the help of an example. So in this example, this is the word context matrix generated from the Wikipedia corpus with the context of 5 context size, that is plus minus 5. So 4 words have been considered for the example: cherry, strawberry, digital and information. And 4 context words have been taken: computer, data, result, pie, sugar. 5 context words, right? So now this cherry as a target word is having context as computer 2 times, cherry as pie, cherry as target word with pie as context word is having frequency of 442, right? So now P of W comma C is the Fij, right? This P of W comma C is the frequency Fij. So that is we are taking the whole so this 3982 is achieved by adding PW is equal to information. That means we are going with information with data. So the word information and data, this is 3982. This is obtained from here. This is 3982, right? And this is the total number of words, right? So PW comma C, PW comma C is Fij, frequency of WC divided by summation of all words with frequency WC. What does it mean? It means that this is the frequency of a word in respect of its context. So frequency of information in respect of data, right, divided by the frequency of all words with respect to all content. So it is W comma C. So frequency of all these when added together, all these will be this 11,716. So this we get PW is equal to information comma context is equal to data as this value, that is 0.3399. Now PW is equal to information, that is for a single word. This can be calculated as P of W as information. So that in this case we need to calculate all the occurrences or all the frequency of information. So the frequency of information is all these counts together, that is 7703 divided by total number of counts. So P of W is summation of F summation on context of the word W divided by summation of WC on FWC, right? Similarly, P of C is equal to data is C is equal to data. When context is the data, we take all the counts of this context, that is 5673, and then we divide it by the total number of words, right? So now this PPMI, pointwise mutual information, positive pointwise mutual information of information with respect to data is log 2, that is log 2 P of W comma C, that is this value, divided by P of W P of C. So P of W is 0.6575 and P of C is 0.4842. So you see, in this way we can calculate the pointwise mutual information for all the words in respect of all the contents, all the context, and we can do this for all words as target words and all words as context words, and then we can populate a matrix. So this matrix is joint probabilities P of W comma C. So these joint probabilities are calculated in this way. So the count of cherry divided by the total count of cherry, the count of cherry in respect of computer divided by the total count of cherry, so that is 0.002, right? So we see that the count of cherry and pi was very high, so their joint probability is also very high. So when we convert these joint probability tables and P of W and P of C into the PMI matrix, we get this kind of matrix. Now we see that very small probabilities are converted to 0 and these higher probabilities are converted to some more higher values. So these negative PMI values may be in resulting of taking the positive values of the PMI. So negative values are also converted to 0. So this is the final PMI matrix that we are getting for these cherry, strawberry, digital information as target words and computer data result, pie and sugar as the context words, right? So we have this formula. Pij is frequency of a given word divided by the probability of W and probability of C. So this Pij is this term, sorry, Pij is this P of W comma C, right? And Pi star is probability of word and P star j is the probability of context, right? So I can relate these, I can again, so I can relate all these here. So this Pij is actually the P W comma C, Pi star is P of W and P star j is P of C context, right? So this Fij is the values in the co-occurrence matrix, right? And this I is equal to 1 to W in respect of its context. Fij is the summation of all the context for a given word, right? And summation of all the words together. So this is the total value. So this term is, this is corresponding to this total value, and this is also corresponding to the same thing, total value, and this is also corresponding to the same thing, the total value, and this is corresponding to these values, right? That is individually for a given word the summation of all the contexts. So for cherry it will be the summation of 2, 8, 9 and so on, and this is in case of PC we do the summation on all the counts of words. So it is actually this thing. So this is the value 61 here, right? Similarly this is the value 7733, right? So this is corresponding to again this value 7703, and this green is corresponding to the summation of contexts. So this is 5653. So this may also go to 5673, and this 3982 is this Fij. So this is Fij is this thing. So I hope now this is clear. How do we calculate the pointwise mutual information matrix with the help of co-occurrence matrix?